Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, I want to talk about successive substitution, but I'm pulled up the slides that I used talking about it with Excel. And basically, the idea is that I can take my equation f of x equals 0 and solve it for one of the instances of x. And this is particularly useful for chemical engineering students because we can use this to solve for roots of the cubic equations of state. And Smith, Van Ness, and Abbott do that, and this is their notation. But we then, have to decide when to stop, and you can go through and write a program and do this. Literally, there are a couple of examples here that we looked at. Some work better than others. Some don't work, and some do work. When this works, it works great. When it doesn't work, it's terrible. But for these cubic equations of state, it does work. But the trick is you have to know whether you want to use the form for the liquid-like solution or the vapor-like solution, and then use an appropriate starting guess for that. So I am going to, let's look at using this one here for a liquid-like solution. Again, this is the cubic equation of state. It's a Pang-Robinson. And I have already set this up in MATLAB so that I have my functions. So A is 1, B is negative 0.9979, C is 0.030302, and D is negative 6.8 times 10 to the negative fifth. And the form of the function in terms of the variable z is negative az cubed plus bz squared plus d divided by c. So that just set up my function. Now then what I want to do is use successive substitution because it is known to work for this function. And so start by just putting in a starting guess. So I want a liquid-like value because I've used a liquid-like form. And I forgot the equal sign. Okay, equals 0.01. I don't need that to repeat. And then what I want to do to set this up as successive substitution is I want to say z equals f of z. So a new z is the function of the old z. And so when I do that, I get an answer that's about half. But now then I can copy and paste. And I can look at this and it's changing. But you'll notice that it suddenly is converging. And it doesn't take very long before you don't really see any significant change, right? It's way out, several digits out. And so therefore, if I have something that I know will converge with successive substitution, I can use this, and it's really easy to do. It seems sort of overkill to write a program for this, but you can when you can do it so easily in MATLAB. Now, be aware that not everything is going to converge. One of the other examples that I had there, x equals 3e to the negative x squared. Let me type that in. So g equals at x 3 times exponential of negative x squared. No, didn't remember the semicolon. And think that I started with a value of x equals 1. And now x equals g of x. And we can see that this one is diverging. So sometimes successive substitution works magnificently, and when it does, it's useful, but it also can fail magnificently also, as in this second example. So that was just a quick little look at how we could do successive substitution using MATLAB. Thank you very much for your time.